Welcome back. I want us to look at example 1 where we are dealing with identities involving compound and double angle formulae. But before we start, I want us to remember the following. Remember, an identity is not an equation. When we're dealing with identities, we want to prove that the left-hand side of the identity is equal to the right-hand side of the identity. So what you can do, you can split these two sides. You can split the left-hand side and the right-hand side and work with them independently and also simultaneously. You can work with them simultaneously. Remember that, okay? And then we usually start with the side that looks more complicated. That's what we usually say. But remember, you can work with these two sides at the same time. And then the concepts you have to remember are the identities that we did in grade 11. Remember those, because now we're going to also involve compound and double angle formulae. You have to remember the identities that we did in grade 11. And then your knowledge about fractions, the operations that involve fractions, that is addition, subtraction, division, and multiplication of fractions is very, very important when it comes to this concept. And also factorization, all the factorizations. Difference of two squares, highest common factor, trinomials. We have to remember those. Okay, right. Let's start. We want to prove that sine 2 theta divided by sine squared theta plus cos 2 theta is equal to 2 tan theta. So the best thing here is to split these two. We have the left-hand side and the right-hand side. Now we don't know that they are equal, but we just want to prove them. So sine 2 theta, already sine 2 theta, there we can see double angle formula there. So this is 2 sine theta cos theta, right, over sine squared theta plus cos 2 theta. Cos 2 theta again, you can see a double angle formula there, but we'll do all the three. Let's start with this one. Let's start with 2 cos squared theta minus 1. Right, so it's going to say sine squared theta plus 2 cos squared theta minus 1, right? We have done the left-hand side. Let's check the right-hand side. Right-hand side, we have 2 tan theta, which is equivalent to 2 sine theta over cos theta. Remember that from grade 11. Okay, right. At the top, we have sine theta. At the bottom, we have cos theta. So if we can get cos squared theta here in this denominator, it will make our life very, very easy. So how can we do that? Okay, we need to get cos squared theta here. Remember from this identity, sine squared theta plus cos squared theta is equal to 1. We can say that cos squared theta is equal to 1 minus sine squared theta. Remember this one, please. Okay, even sine squared theta is equal to 1 minus cos squared theta. So we can write that. So now we can replace sine squared theta with 1 minus cos squared theta here. So we have 2 sine theta cos theta. Then you replace this with 1 minus cos squared theta. Then plus, you can remove the bracket here. 2 cos squared theta minus 1. Okay, then this side is 2 sine theta cos theta. Right, then negative cos squared theta plus 2 cos squared theta, that is cos squared theta, isn't it? And then 1 minus 1 is 0. So we remain with 2 sine theta cos theta over cos squared theta. And then we have 2 sine theta cos theta, right? And then we can divide this. 1 cos theta here, we'll take 1 cos theta there. We remain with 2 sine theta over cos theta. And then this side also is 2 sine theta over cos theta. Okay, we can leave it like this. We have proved that the two sides are equal, right? So there's no need to say 2 tan theta is equal to 2 tan theta. Is fine like this. So therefore, the left-hand side is equal to the right-hand side. We've proved that. Right, what could have happened if we said maybe we're using 1 minus 2 sine squared theta. Let's see. Are we going to get the same thing? For this cos 2 theta, if you used 1 minus 2 sine squared theta. Let's see. So we have our left hand side and our right hand side. So sine 2 theta, we say it is 2 sine theta cos theta, and then sine squared theta, then plus, and then we're saying this one 1 minus 2 sine squared theta. Okay, then this side we have 2 sine theta over cos theta. Now we have sine squared theta there. Okay, how can we get cos theta from those? Alright, so what do we do? Right, let's simplify this first. We can remove this bracket here. It becomes sine squared theta plus 1 minus 2 sine squared theta. What do we get? We get 1 minus sine squared theta. So 2 sine theta cos theta, and then we get 1 minus sine squared theta. So what we have here, we said this, we discussed this, said 1 minus sine squared theta is equivalent to cos squared theta, isn't it? From the grade 11 identity that we discussed in the previous one. So we say 2 sine theta cos theta over cos squared theta, then 2 sine theta over cos theta, right? And then 1 cos theta takes 1 cos theta from this side. We remain with cos theta as the denominator. So we have 2 sine theta over cos theta, and then this side we have 2 sine theta over cos theta. We have proved that the left hand side is equal to the right hand side. Okay, done. Right, now the last one. We could have used cos squared theta minus sin squared theta here. Let's see. Left hand side is equal to right hand side. So we have sine 2 theta. Right, sine 2 theta will give us 2 sine theta cos theta over sine squared theta plus, then you have cos squared theta minus sine squared theta. This one is easy. Sine squared theta minus sine squared theta is 0 there. Then we have 2 sine theta over cos theta, right? Then sine squared theta minus sine squared theta is 0. We remain with cos squared theta. So 2 sine theta cos theta over cos squared theta, then 2 sine theta over cos theta. 1 cos theta takes 1 cos theta in the denominator. Then we remain with cos theta in the denominator. So it's 2 sine theta over cos theta. In this side, 2 sine theta over cos theta. Then we prove that the left hand side is equal to the right hand side. Okay, so we have proved the identity.